Hello everyone. In this video we will see how to draw the layout of 1-bit SRAM cell in Microwind. This is the schematic of 1-bit SRAM cell where you can see the inverters where P1 and N2 are forming one inverter and P2 and N3 is forming another inverter. These two inverters are connected back to back. The output of this inverter is, let us say this is Q, and output of this inverter is Q bar. Okay. And the transistors N1 and N4 are called as excess transistors, where the gate of these transistors are connected to word line, that is WL. If I want to write a data into the memory, the word line must be connected to 1 so that N1 and N1 and N4 will be on, and whatever the data that is present on the bit line will be written into the memory. We'll use this schematic in order to draw the layout in the Microwind. Now let us draw the layout in Microwind with the help of a schematic. As we have seen in the schematic, we require two inverters. So let us first form an inverter in the Microwind. Take a PMOS transistors. So I have taken a PMOS transistor here, and now you take a NMOS transistor. Place these transistors properly so that we can join the gate of both the transistors. Take the polysilicon. Let me place them properly. Okay. Now connect the gate terminals of both the transistors. Okay. Now similarly, connect the drain terminals for the output. Okay. Now this is the one inverter pair. What we will do is we'll copy this and paste it here so that this will form another inverter. As you can see in the schematic, the output of the input of one inverter, you can see here P1 and N2. The input of this is connected to the output of the another inverter. Similarly for this one, where input of this inverter is connected to output of the another inverter, we'll make the connection for the same. Okay, this is the output of one inverter. Okay, we'll connect it to input of another inverter. Now what I will do is I will extend the poly of this inverter. Okay, and extend the metal one. Okay. Now you connect them with the help of metal poly contact. Okay, this is connected. Similarly, input of this inverter is connected to the output of this inverter. Okay, connect them with the help of a contact. Okay, so we have connected them with the help of a contact. Now we need to take two more NMOS transistors. generate a device. So place one NMOS transistor here and take one more NMOS transistor. Okay, keep that transistor here. So let me place them properly. Okay, these are the excess transistors that we have seen in the schematic. Okay, so gate of these two transistors must be joined. So take a polysilicon and join the gates of these two transistors. That will form our word line. Okay, join this. This is your word line. Okay, let me label this one. So this is the word line, WL, assign. Okay, now in the schematic, this must be connected to bit line. Okay, so this is our bit line. Here, assign it, and this is the bit line bar. So you can click on last clock and assign. So we'll see the bit line on in the output window. Bit line bar, anyway, it is a it's okay if it doesn't appear on the output waveform. Okay, now for the output, this is our Q. And Q bar. So I'll make it as not visible in simulation, assign. Now what we need to do is in the schematic, if you can see, this output must be connected to the terminal of N4. So I will connect it. So take a metal one. Okay. Connect this metal one here. Okay. Similarly, this must be connected here. Okay. This is the connection for the excess transistors. Now you need to connect a VDD and VSS. Okay, extend this metal. Okay, for the VDD connection. Okay, so here you need to connect a VDD and VSS must be connected here for the NMOS transistors. So connect the VSS and connect VDD to N-well. Okay, this is the N-well. Connect the VDD. Okay. Now your layout is ready. You can simulate this one. So simulate this one. You can now see the waveforms here. So this is the waveform for the bit line, this is for word line, and this is the output Q. You can see when the word line is high, the bit line value 1 is written in the memory. You can see Q is 1. Okay, now here WL is 0. The previous bit will be stored in the memory. You can see 1 is there. And when word line is 1, again whatever the data that is present on the bit line, that is 0, is written into the memory. You can see here. Okay, so these are the waveforms for 1-bit SRAM cell. Now on this side you can see the power dissipated, that is 11.036 microwatt. You can change the time scale in order to see the compressed or expanded version of the waveform, and you can even evaluate it for the minimum, maximum or AV as well as for the frequency. For that you need to reset and again simulate it again, so that you'll come to know at what frequency your circuit is working. Thank you.